Fundamentals of Computer Architecture and Organization. 1. Introduction. Computer architecture versus computer organization. Architecture refers to the system's overall design, focusing on how components like the CPU, memory, and input-output devices interact. Organization deals with the physical layout and implementation details, how data moves between components and how the hardware executes instructions. 2. Functional units of a computer. Input unit, devices like keyboards, mice, and microphones that feed data into the system. Central processing unit, CPU, the brain of the computer, responsible for executing instructions. Divided into the arithmetic and logic unit, ALU, and the control unit. Memory, primary memory, RAM, volatile storage used during processing. Secondary memory, hard drives, SSDs, non-volatile, long-term storage. Output unit, displays results from monitors, printers, etc. 3. Bus structure. A bus is a communication pathway that connects different components. Data bus, carries actual data. Address bus, specifies the location of data. Control bus, manages data and signal flow, ensuring only one component transmits at a time. 4. Instruction types and execution. Instructions are fetched, decoded, and executed in a process called instruction sequencing. There are different instruction formats. Free address, add A, B, C adds values of A and B, stores in C. To address, add A, B adds A and B, stores result in B. One address, add A uses an accumulator for operations. Zero address, uses stack operations like push and pop. Straight line sequencing is the process where instructions are executed sequentially unless a branch or loop changes the flow. 5. RISC versus CISC architectures. RISC, reduced instruction set computing, simple instructions, faster execution, and pipelining. Often used in portable devices. CISC, complex instruction set computing, more complex instructions, smaller code size, but slower execution. Typically used in desktops. 6. Instruction execution process. Fetch, retrieve the instruction from memory. Decode, determine the operation to perform. Execute, carry out the operation, such as adding or transferring data. 7. Example of assembly language execution. Assembly. Load R1, 10. Load 10 into register R1. Load R2, 20. Load 20 into register R2. Add R1, R2. Add R1 and R2, result in R1. Store R1, result. Store the result. This simple example shows how instructions are processed through loading values into registers, adding them, and storing the result in memory. 8. Conclusion. Understanding the basics of computer architecture and organization is essential for optimizing system performance and energy efficiency. The choice between RISC and CISC architectures depends on the system's needs, balancing complexity, speed, and power consumption.